Hi, in this video we are going to discuss about basic probability concept that what we need for the learning machine learning concepts. First we will start with the basic what is the population, what is the sampling, the difference between these two. Then we are going to discuss more important distribution in the machine learning, that is the Gaussian distribution, because some of the models, few of the models we are assuming the data is in the Gaussian distribution, then only we will apply the models. That's why. Okay, these things are most important. Let's go into see what is the population and the sample. Population is a data points, is a data points, whole data points. In simple words, whole data points. And sample is a also data points, but it is a subset of the population, and these points we are picked randomly. For example, let's consider of the Indian population is there, like 130 crores is the population as there. Okay, and the sample means picking the random people in India from all the states. It's a, like it is a 30% is a sample data. Okay, why we need the population and sample? Why we need these two things differently? Because sometimes it is difficult to find the calculations on population data. That time we are using the sampling data. For example, like if you want to find the average height of a person in India, for that we have to find the heights of 130 crore people. It's very difficult. At the time we are using the sampling technique, and we will find the mean, sampling mean, and the mean that we find here is mu, and here the mean find in the sampling is x bar, and these means are approximately equal. Okay, if the number of samples is increases, the closeness is very more. That is the difference between the population and sample. Okay, now let us consider we have a data, and the data also has some structured data. When we in the data we have a structure, for the models it is very easy to find the patterns from the data, and from the models we can expect more performance. That's also a good thing. And what is the meaning of a structure? The structure meaning it is following certain distribution like Gaussian distribution, binomial, Pareto, skewed. We have a lot of distribution. If we followed one of the distribution, and we can believe the data for first most thing, and the models also believe and they give best results. That was a fair thing. And in the here we are going to discuss one of the generic distribution, that is a Gaussian distribution. Here this plot represents the Gaussian distribution plot. It is a PDF file, PDF plot. Generally PDF plot represent the x value is the data points, and the y value is the number of points in the, that means the percentage of points in the data with that value. Here 0 is a point in the data, the 40% of points are 0 values only. That was represented, and -1. Here 20% of points in the data is -1 value. Similarly 20% of points are 1 values. That was, and it is represent PDF plot. And here also same thing will be happen in the Gaussian distribution also, and a few more important things are there in the Gaussian distribution. Okay, here in the Gaussian distribution, the middle, the center, we have higher the values, more percentage of points will be there. And this is also called mean point. When we are moving away from the mean, number of points are decreasing. Okay, and by moving away, we have very less points when you're moving away. And let's write the equation to get better understanding. It's a PDF curve. Okay, and the Gaussian curve we will represent like normal distribution. Mu means mean, and sigma square is a variance. Because of it is a PDF curve, we can also represent like this: probability of x equal to x 1 by 2 pi sigma square, this is in the root, and exponential of minus x minus mean whole square to sigma square. This is the equation of this distribution. Okay, let us consider mu equal to here mu equal to mean of data and sigma square variance of data. Let us consider mu equal to 0 and sigma square equal to 1. What will be happen? We will get the equation probability of x equal to 1 by root of 2 pi exponential minus x square by 2. Let's see how if this plot is following this one or not, because here also 0 mu equal to 0 now. If the value of x increases, then the x square value also increases. Then because it is in the exponential of minus exponential value, the value is going to decrease. That means probability value is going to decreases. Okay, that thing we can observe this side. And x value is decreases, then x square value decreases, and the probability value is going to increases. That is the in this side we can observe. And now if we take the negative x value, if the negative x value increases, then the x square value is going to increases, because we are making the square of the point. Then the probability value is going to be decreases. This side is moving like that. And when negative value is decreasing now, then the x square value decreasing, then the probability value is going to increasing. We are moving this side now. Okay, and we can also one of the thing, this Gaussian distribution is symmetric about the mean, and we have mu mean and the sigma square. These are the two parameters in the Gaussian distribution. Let's see what will be happen when we changing the mean and variance. Here we can see in this plot, the first one is mean equal to 0, sigma square is a 0.0, this for this plot. And here there is 3 points, the mean is 0. That means for this one, for these 3 points. And here we only varying the variance. By varying the variance, the plots are spreading. That means our data also spreading, it represent. And when the mean was changing, that represent our data is shifting. This is the thing we can learn from the Gaussian distribution by observing the data is in Gaussian distribution. Let's discuss few more things from the Gaussian distribution that will make it is more interesting about the Gaussian distribution. Here this is the mu plus sigma, this one is the mu minus sigma. Okay, this was the sigma square we can consider. Okay, variance is 1, here the variance is -1. Between these two values we have 68% of data points. Okay, and mu minus sigma square, mu plus sigma square, between these 2 points we have 95% of data, and between mu minus 3 sigma square, sorry, here we have 2 sigma, 3 sigma square, and mu plus 3 sigma square, here we have 99% of data points are there between 3 sigma square values, between 3 variance values. Okay, and but all the things, what is the necessary, why we need these all the things, that point we have also know. If we given, some person is given mean value and the sigma square value, that means variance, and if we tell the data is in the Gaussian distribution, at the time we can tell that guy we have mu minus 3 sigma square to mu plus 3 sigma square. Between this range we have 99% of data